Okay, so if you were with me for my last video on programming basics, you saw that a couple times I typed some stuff in incorrectly and it gave an error instead of doing what we thought it would do. So how do you usually figure this out on your own if you don't have me to tell you that something was misspelled or I did something wrong? The process of problem solving with computers is called debugging, so that's what we're going to go over today. So again, I'm Michael Leonard, your TA for C100 and C200, and we're going to talk about debugging. So basically, debugging is just problem solving. The difference is when you start having problems with a computer, people are less familiar with how computers work. So the idea of basic problem solving kind of goes out the window, and people kind of freak out. But when it comes down to it, working with a computer is the same as pretty much doing everything else in your biology wet lab. So in the case on the right, I can ask, what happened here? And I show you a picture of a hideous gel, and just by working through the steps or maybe trying to figure out what you did, you might find out that the protein concentration was way too high. You might figure that out just by looking at this, or you might figure it out by problem solving. But that's the same exact thing you would do for a computer error. So on the left, I ask you, what happened here? First, we printed the first line from the program that we went over before, and it says, welcome to Chem C100, that's correct. And then you want to print the range from 0 to 5, except for this time it tells you syntax error, invalid syntax. As you saw multiple times, I typed out a couple things incorrectly, and in this time there's a typo where instead of print, I typed out the word pring, and pring doesn't do anything in programming. So it gave an error, and that's pretty much just what happened. I typed pring instead of the word print. Okay, so let's talk about the word debugging itself. Where does it actually come from? In the 40s, we all heard stories how computers used to take up the size of the entire room, and now you can put them in your pocket with a cell phone. So in the 40s, there was a computer called the Harvard Mark II, and this lady, Admiral Grace Hopper, was programming it, and she noticed that it wasn't working exactly how she thought it would be working with the program that she was typing into it. So she did some problem solving, and she looked around, and what she actually found was a bug, a moth, just in the computer itself. And so when she removed the bug, she termed the coin debugging, because that's literally what she did to this computer. So here's what she was working with. Behind all these panels are a bunch of wires and vacuum tubes or whatever they were using at the time. And somewhere in this big old computer is a tiny little moth that got stuck somewhere and was causing a whole bunch of problems. So she debugged the computer. That's just where the word comes from. It might seem kind of oversimplified because we're just talking about problem solving, but whether we're talking about problem solving computers, which would be called debugging, or we're problem solving anything else, there's a certain number of steps that you go through when you're solving a problem. So the first step is issue recognition. You're trying to just identify what happened in the first place, or identify that something even wrong happened in the first place. Next, you do intelligence gathering, which is kind of just like understanding why it went wrong. And then there's diagnosis and prescription. I put these two together because they're very similar. You understand where it went wrong, so what line of code or where in your code. And then once you actually see what happened, you can kind of plan out how you should fix your line of code, if there's a typo or whatever. And then you can get to the response phase, which is fixing the bug. And finally, you want to make sure that it works the way you intended, so you verify that your problem is null solved. So again, just like with your gel, you can see a terrible gel. You recognize there's an issue. You can start to look up, are there other gels I've seen before that look like this? Like, what happened? And then in your case, you can go back to your tube with your protein in it, and you can check the concentration, and you can see, oh, the concentration was way too high. I never actually diluted the sample. The response would be to fix the bug, which would be to dilute your sample, and the verification would just be to run another gel. and make sure now that it works as intended. So that's it. You're just problem solving, except for this time we're using a computer instead of whatever other problems you might have. So again, we can just work off of a single example. In this case, when we got to the line list of students, we assigned the names Seinfeld, Kramer, and George to this list. Remember, it's assignment because we use the equal sign. We wanted to get the student with the number 1, which is the second student in the list, which is Kramer. And then let's say we wanted to find the 100th student in the list, which would be student number 99. And we got an error that says index error, list index out of range. So just right off the bat, just because I went through this with you, it's very clear that you don't have 100 students in your class. And if you don't have 100 students in your class, you can't get the name of the 100th student. But let's say you'd never even thought about this before, and you're going to go through it step by step, just like we listed in the steps of problem solving before. So step number 1, issue recognition. Figuring out in the first place that something went wrong. So right off the bat, you know that instead of the name of a student, like Kramer, George, Michael, whoever, you got a line of text that says traceback, most recent call line, and then you got index error, list index out of range. So a student named index error, list index out of range doesn't sound like any name I know. You kind of just identify right now that this did not do what you intended to do in the first place. So if you notice that your program crashed at all and you didn't just keep going, congratulations, that's step number 1 of problem solving. You identified that you have a problem. You recognized that you have an issue. Just a little aside, a lot of bugs in computer programming aren't as obvious as trying to get the 100th student in a class of 3 people. 2 that I want to just kind of go over because they're a little bit interesting. There's one bug with the computer that NASA was using, or the software actually, that they didn't know about the hole in the ozone layer for a long time because the software that they were using to analyze the ozone layer ignored unexpected deviations between the ozone layer. So if the whole point was to identify places that look weird and your program says ignore everything that looks weird, you're not going to know about a giant gaping hole in the ozone layer, which they didn't for about 6 years. The second one, there's a radiation therapy device from a long time ago called the Therac 25, and instead of people getting a dose of the radiation that they needed, it gave them a dose 100 times higher than the dose that they were expecting. This is awful. This would be like going in for an X-ray and it blasts you in the face with 100 times the X-rays you were expecting. So that's terrible. And they figured out that it only happened if the person pressing a button to shoot the X-rays pressed it at just the wrong time. And there's a complicated reason for this, but the idea is that it didn't always do it every time. So it was hard to identify what actually happened. So in both cases, the programs appear to be running the right way, but in actuality, you did have a hole in the ozone layer or a hole in the person from radiating them way higher than they should be. So these are 2 instances that sometimes problems aren't always as obvious as what we're talking about today. Just keep that in mind, that if it's not working the way you intended, something probably went wrong. And that's the first step of solving the problem, is identifying that you have a problem. Okay? The second step is understanding what actually went wrong. So the most useful line of code here is the line that says index error, that tells you what type of error you had, and it gives you a little description. The list index, which we know is the number of the student, is out of the range of the students. So that's a little bit helpful, a little bit cryptic if you don't know what it means. On the next slide, I'll give you a list of common errors. There's different types. There's syntax errors, there's the index error, there's things called, we'll see it in the next slide. But if you didn't know what this means at all, which, yeah, it does look a little bit cryptic, You can do a couple different Google searches to figure out. That's what this is. This step is figuring out what actually happened. So you can Google for Python index error, or just what the phrase itself, list index out of range, means. That's not specific to Python. Or if you're only looking at Python, you can say Python list index out of range, kind of just to figure out what actually happened. So after all these Google searches, or just because I told you, we can see that the problem is we're asking for a student that doesn't exist. And so you can't have the name of the student if the student doesn't exist in the first place. As promised, here's a list of some common Python errors that might come up in this class. The full list of them is on this website. You can click it, and it'll give you just pretty much information overload of all different types of errors in Python. But the ones you'll probably end up seeing the most, I'll list on this slide. So a syntax error, it's kind of just a general overview for there's a typo somewhere in your code. A name error is a little bit more specific. It's a typo probably in your variable name. We saw that a couple times when I misspelled the word students in the last lecture. You can, when you're dealing with a list, and this is our scenario, you get an index error, which you're asking for an element that doesn't exist in your list. For example, asking for the 100th student in the class. When you're working with a dictionary, there's a very similar error, asking for an element that doesn't exist in a dictionary. For example, we were asking for the student named Barack Obama. He probably doesn't exist in our class. There's errors involving functions where they expect either a number or a letter or a name, and you give it something it's not expecting. So if you want the range between apples and oranges, Python's not going to know what that means. It's only looking from a range from 0 to 5 or 0 to 6, not apples to oranges. There's an error called indentation error, which is when you accidentally type the wrong number of spaces when you're indenting code, which we'll talk about a little bit later in the class. But sometimes the spaces or tabs that you're typing in do matter, and that's this error. When you're working with libraries and you told it either a misspelled name of a library or a library that doesn't exist or a library that isn't installed on your computer, you get the import error, just an error with importing a library. And if it doesn't fit in any of these categories but still gives you an error, you'll probably get a runtime error, just an error that happened at the time that you ran the program. And it doesn't really fit into any other category, but it usually tells you what's going on in the explanation. So, I mean, at this point it's pretty straightforward. We know that our problem is we're asking for the 100th student in the class. There is no 100th student in the class. There's only 3 people in the class so far. But the next step is to figure out where it happened. So when you run everything at the same time, it would tell you what line the error actually happened, just like we saw in the last exam. In the programming lecture, we ran everything at once, and there were separate lines being run at the same time. When you're using the Python interpreter, you type in everything line by line. So when it says the error happened in the file standard input, which is just typing stuff in, there's input and output. So input means you're typing things in. Output means it happened when it was trying to output your text or whatever. If you're only inputting one line at a time, chances are it happened on line number 1, because there's only one line. So it tells you the last thing you typed in, list of students, crashed. That's what this means. So again, just to kind of read it out, in the standard input, the last line you typed in, there was an error. And the error was index error, and specifically it says the list index was out of range. One thing to notice is in the line before, this did work. We asked for the student with the number 1, and that gave us Kramer, because Kramer is student number 1. Kramer is the second student given the number student number 1. So the only thing that changed between last time and this time is that instead of asking for student number 1, we're asking for student number 99. And so that must be what happened. So because this isn't a typo or it's more of a conceptual kind of error, Fixing this would be a little bit more tricky. So what do I mean by that? Let's just say that we assume that the order of the list is in the order that the students enrolled in the class. So the last person to enroll in this class was named George, because Seinfeld, we're saying, was the first student to enroll in the class, Kramer, we're saying, was the second student, and George was the third student. So for the sake of this exercise, let's say we were just trying to get the last person that enrolled in the class. And we assume that if we give it a really big number, it would give us the last person in class. But Python doesn't know that's what you meant when you asked for the 100th student. It only knows how to give you the name of the 100th student. And if there's not 100 students, then it gives you an error, which it did. So again, let's pretend like we were just trying to find the last person that enrolled in the class. Pretty much any time you have a problem like this, chances are somebody else did too. So instead of trying to figure out why what we did didn't work, we can just Google in Python, how do you return the last element of a list? And we see that now our assumption was wrong. The proper syntax is list of students, and you give it the -1 element of the list. So yeah, it's not a great fix, because we're assuming that we tried to do something which doesn't make any sense. But we're all smart people here, so let's just say we were trying to help out someone a little bit less smart than we were. And they were trying to do the last person in the class by a really high element number. So now the response is to actually fix the bug. This time, instead of incorrectly assuming that it's just going to give us the last person from a very high number, now we put in the proper syntax and we press the Enter key. So by pressing the Enter key, we're trying to verify that what we're doing works. So now if we try to find the last person enrolled in the class, we can say the list of students with the -1 index, which is the last element of the list, and it returns the name George. The problem is now solved. So verify that the bug is now fixed. We did. The name George was returned, and we fixed the bug. Tape it to your lab notebook, because it's done. And that's debugging in a nutshell. So a lot of times, these problems aren't as simple as just misspelling something or having a false concept of how you return something from a Python list or dictionary or something like that. Not every problem is going to be easy to solve. So first, please try to Google your problem and see if chances are other people are going to have the same problem. But I understand that this stuff's really complicated. There's a lot of stuff right now that we're not telling you that is just going on in the background, and we don't expect you to even think about this stuff in this class. And so if you Google something that has a more complex problem, you're going to get a really complex answer, and you're probably not going to know what they mean when they're talking about memory or your CPU or whatever you're trying to do. If it sounds like it's more complicated than it actually is, then chances are it's more complicated than it actually is. So when that happens, come see me. I'll be in discussion. I'll be in my office hours Tuesdays at 3 o'clock in the Young Hall library space on the 4th floor in the little C cubby of the library. And I'm here to help. So we want you to figure out why you might be having problems with these things. So that's all I'm going to say about debugging. It's really just problem solving with computers. And now, hopefully it's a little less intimidating at this point. All right, I'll see you in class. Bye.